So, good morning, students. Today we are to discuss the lecture number 4 of automobile engineering. So, in previous lectures, what did we discuss? We discussed the different components of IC engines. So, today we are to discuss some another components of IC engine. Guys, here, see here, this is inlet and exhaust valves. So, what is the use? You see here, these are the designs. These are the figures of the inlet and exhaust valves. Look at these figures, guys. Okay, there is a connection of this inlet and exhaust valves. The valves are commonly a mushroom shape poppet type. What is the shape? It is the shape of the mushroom. We know the shape of the mushroom. They are provided either on the cylinder head or on the side of the cylinder for regulating the charge coming into the cylinder or inlet valve and for discharging the product of combustions through the exhaust valve from the cylinders. Yes, we know the guys, this is our cylinder. Okay, from the inlet valve the charge is entered, and from the exhaust valve after the combustion the gas will be come out. This is a simple concept. Okay, another is what is connecting rod. So it interconnects the piston and crankshaft. We know there is a piston will be there like that, and there is what is the connecting rod which connect this crankshaft. Okay, this is the crankshaft. Okay, we know this is the what is connecting the rod will be there. So interconnect the piston and crankshaft and transmit the gases forces from the piston to the crankshaft. The two ends of the connecting rod are called as small end and the big end. The small end is connected to the piston by gudgeon pin and big end is connected to the crankshaft by crank pin. This we observed here. There is a small is what is gudgeon pin and big is what is the there is a crank pin. If you observe in diagram, where is the design of this crank connecting rod? This ones. This is your connecting rod, where is connecting piston through the gudgeon pins and connected to the crankshaft by the crank pins. Now another component, what is the crankshaft? Okay, what is the crankshaft? So look at the design of this crankshaft, guys. Okay, so it converts the reciprocating motion of the piston into useful rotary motion of the output of the objects. Means reciprocating motions, means conversion of the one motion to another motions with the help of this what is the crankshaft. Means convert reciprocating motions to and fro of the pistons into what is a rotary motions. In the crankshaft of the single cylinder engine, there is a pair of the crank arms balance weights. The balance weights are provided for the static and dynamic balancing of the rotating system. The crankshaft is enclosed in a crankcase. So this is the we know the diagram we observed here, guys. Another what is the piston rings. So these are the piston rings will be there, which is mounted over the pistons. So piston rings fitted into the slots around the pistons. So there is a piston will be there, and there is a small slots. So on the slots, on the slot, this piston ring will be fit. Provide the tight seal between the pistons and cylinder valve, thus preventing the leakage of the combustion gases. So when it put into the cylinder, there is no any leakage from the gases, no leakage from the gases. So this will be achieved through by using the piston rings. So we know the another gudgeon pins. We know the gudgeon pins. It forms the link between the small end of the connecting rod and pistons. There is a connection of this gudgeon pin. Camshaft. Okay. The camshaft and its associated parts control the opening and closing of the two valves, which inlet and outlet valves is controlled with the help of this camshaft, guys. The associated parts are push rods, rocket arms, valve springs, and tappets will be there. This shaft will also provide drive the ignition system. The camshaft is driven by the what is crankshaft. This crankshaft is connected to the camshaft. Camshaft is operated the inlet and outlet valves. Okay. Now another, this is the cams. So these are made as a integral parts of the camshaft and are designed in such a way to open the valves at the correct timing and to keep them open for the necessary durations. So this is the cam. You observe here in the diagram. You see here there is a connection of the cam will be there. If you observe here, crankcase, this is the crankshaft, connecting rod, crank will be there. There is a camshaft inside the figure also, guys. Here this is the intercam. Okay, this is the cam will be there. There is a gudgeon pins, there is a connecting rod in this way. Okay. So now another is what is flywheel. So it is a wheel mounted on the crankshaft which store excess energy during power stroke and retain the energy during the other stroke and maintain very constant output torque on the crankshaft. This is the function of the flywheel. Now this is the figure you observed here. There is a connecting rod will be there. This is our crankshaft. There is a pistons. On the piston there is a piston ring. These are the inlet and outlet valve will be there, guys. Okay, this is the inside structure of the cylinder, piston engine cylinder. Okay, so here terms connected with the IC engine. What are the terms? So you see here, first is bore. So inside the diameter of the cylinder is called as bore. If you observe these complete portions, this is called as the bore of the cylinders. Another is what is stroke. Stroke means what is the linear distance along the cylinder axis between two limiting positions is called as stroke. If this distance, if you observe, this is the limiting of the piston which is operating in between, that is stroke. It is shown by the letter A, L, and bore is shown by the letter B, or sometimes it is D also. There is what is another is TDC, top dead center. So this is called as what is TDC position of the piston cylinder. Topmost position of the piston towards cover end side of the cylinder is called as TDC. Another what is bottom dead center, what is BDC. These positions, if you observe here in piston cylinder, the lowest position of the piston towards the crank end side of cylinder is called as BDC. Then what is clearance volumes. So if you observe here, there is a clearance gap will be there. Okay, this is the clearance if you observe here. So the volume contained in a cylinder above the top of the piston when piston is at the top dead center is called as clearance volumes. When the piston reach here, guys, piston in at upper linear travel, there is a gap in between cylinder head and this top position of the piston. There is a connection. There is a what is clearance volumes. This is shown by later we know the VC. Swept volume. The volume swept through the piston is moving between TDC and BDC is called as the swept volume. It is shown by the letter VS. When piston is moved from this position to this TDC to BDC, so this portion it is called as the swept volume VS. Now what is compression ratio? It is the ratio of the total volume of the cylinder to the clearance volume. So total volume upon this clearance volume, it is called as the compression ratio, guys. It is shown by the letter R. We know that V upon VC. So what is four-stroke pass ignition engines? It is called as what it means SI engines. It is called as the spark ignitions. So in four-stroke engine, the cycle operation is completed in a four-stroke of the piston or two revolution of the crankshaft. This crank will be theirs. Okay, we know this crank is connected here to the connecting rod. This connecting rod connected to the piston inside the cylinder. So there is how many revolution? Two revolution. The crank will be come here. Next time once again crank will be come here. That's why it is called as the four stroke. So during the four stroke, there are 5 events to be completed. One is suction, compression, combustion, expansion and exhaust. Each stroke consists of 180 degree of the crankshaft rotation, hence 4 stroke cycles completed to the 70-20 degree of the crank rotations. It's 2 revolution, 360 plus 360. It is what is 720. So the cycle operation for idle 4-stroke SI engine consists of the following 4 stroke. What is suction or intake, compression, expansion or power stroke, or exhaust. So you see the guys figure here. Figure. This is the intake stroke. Okay. So intake, there is a connecting rod. There is a crankshaft. There is a piston cylinder arrangement. Intake valve. Inlet through the intake port. Inlet valve. Air fuel mixture will become. This is the exhaust valve. So piston is where the downward movement of the piston draw the air fuel mixture into the cylinder through the intake valve on the intake stroke. When piston is coming downward, all the air is enter inside the piston cylinder arrangement. On the compression stroke, the mixture is compressed by the upward movement of the piston with the both hole is closed. So during the compressions, whatever air will become, this piston is compressed, move from TDC to where BDC positions. During that, both the valve will be closed and there is a compression, means increase the pressure, decrease the volume and increase the temperature during the compression stroke. So, okay, ignition occurs at the beginning of the power stroke and combustion drive the piston once again downwards. So once the compression will be completed, there is a ignition, combustion will be there. Due to the combustion, the excessive pressure will be developed and this pressure act on the piston and once again the piston move in downward directions. So on the exhaust stroke, once again after the exhaust stroke, whatever the combustion gas will be there, okay, this combustion gas is removed. Once again the piston is moved from this BDC position to here on TDC positions and through the exhaust valve all the gases will be come out through the engines. What is two-stroke engines? So in two-stroke engine the cycle is completed one revolution of the crankshaft. Means power is getting only the one revolution of the crankshaft in two-stroke engine. That's why it is called as two-stroke. The main difference between the two-stroke and four-stroke engine, it is the method filling the fresh charge and removing the burned gases from the cylinder. In four-stroke engine, these operations are performed by the engine piston during the suctions and exhaust stroke respectively. So in two-stroke engine, the filling process is accomplished by the charge compressed in the crankcase or by the blower. The induction of the compressed charge move out of the product of combustion through the exhaust ports, guys. So therefore, no piston strokes are required for these two operations. Two strokes are sufficient to complete the cycle, one for compressing the fresh charge, another for expansion or power strokes. So this is the diagram of the two-stroke engine. This is the spark plug. There is this compression will be. This is the transport port. There is a vacuums. There is a carburetor connections. Okay, there is the exhaust ports, guys. This is the connecting rods. So inside the inlet and exhaust valve, there is a use of the inlet port or outlet port. So comparison of 4-stroke and 2-stroke cycle engines. So you see here aspects 4-stroke engines and 2-stroke cycle engine. So what is the completion of the cycle? The cycle is completed in 4-stroke of the pistons or in 2 revolution of the crankshaft. Thus, 1 power stroke is obtained in every 2 revolution of the crankshaft. In 2-stroke, the cycle is completed into the 2-stroke of the pistons or in 1 revolutions of a crankshaft. Thus, the power stroke is obtained in each revolution of the crankshaft. यहाँ पे हमको 2 बार घूमने से मिलेगा, यहाँ पे एक ही बार घूमने से मिलेगा crankshaft power. Okay. Flywheel required heavier or lighter. So because of the turning movement is not so uniform, hence heavier flywheel is needed in 4-stroke. More uniform turning movement, hence lighter flywheel is needed. Another third classification in difference power produced for same size of the engine. So again, because of the 1 power stroke for 2 revolution, so power produced for the same size of the engine is small or the same power of the engine is heavy and bulky. Here, because of the 1 power stroke for 1 revolution, and power produced for the same size of the engine more. In 2-stroke, more power, actually about 1/8 times or the same power of the engine, light and compact. cooling and lubrication requirements. So because of the one power stroke in two revolution, lesser cooling and lubrication requirements, so lesser rate wear and tears. There is a less because of the one power stroke in the one revolution, greater cooling, lubrication required. So great rate of wear and tear of the engines. Value and value mechanism. The four-stroke engine contains valve and valve mechanisms. Okay. Two-stroke engine have no valves but only a ports. Some two-stroke engine are fitted with a conventional exhaust valves. Initial cost. Because of the heavy weight, complication, valve mechanism, higher the initial cost. Because of the lightweight, simplicity, due to the absence of valve mechanism, it is cheaper in initial cost. So comparison of the SI engine and compression engines. SI and CI. SI means spark, CI means compression. So thermodynamic cycle, it is used auto cycles. In CI engine, it is used diesel cycle for a slow speed engine. Fuel is petrol, fuel is diesel. It is also used another cycle, dual cycle for high speed engines. Air fuel ratio, what is 10:1 or 20:1? Here is air fuel 80:1 or 100:1. Combustion happens, what is here spark ignition, here it is compression ignition. Maintenance cost, minor maintenance is required. Here is what is major overall required but less frequently. Initial capital cost is low, higher due to the heavy weight, sturdy construction, costly construction, 1.25 to 1.5 times. Noise and vibration is less here. Here more idle noise problem. Use moped, scooter, motorcycle, simple engine, passenger car, aircraft, buses, truck, locomotive, tractors, earth moving machineries, and stationary generating the plants. So another comparison, guys, petrol engines and diesel engines. So in petrol engine, what is air petrol mixture is sucked in the engine cylinder during the suction stroke. In diesel engine, only air is sucked during the suction stroke. Petrol engine, another spark plug is used. Here is employed as injectors. Power is produced by spark ignition. Power is produced by the compression ignitions. Thermal efficiency, what is 25%? Here thermal efficiency is 40%. Occupies less space, occupies more space. More running cost. Here is what is less running cost. Light in weight, heavy in weight. Fuel is petrol costlier, fuel is diesel is cheaper. Petrol being volatile is dangerous, diesel is not a dangerous, not it is non-volatile. Pre-ignition possible, pre-ignition is not possible. Work on auto cycles, work on diesel cycle. Less dependable, more dependable. Use in cars, motorcycle, use in heavy duty vehicles like truck, buses and heavy machineries. Okay guys, so I stop here. In next lectures we will be discuss the engine balancings. Okay, so thank you very much.